the more you make your data available and the more people can demand data and the more people can deliver data and make it self-serve, and you create that culture of a marketplace of data, a marketplace of APIs that is self-service. Things have good contracts, have API contracts, but data can change and data can flow freely through the organization. The entire org is going to move much, much faster.
Hi, this is your host Swapnil Bhartiya and welcome to TFiR Let's Talk. And today we have with us once again Tanmai Gopal, co-founder and CEO of Hasura. Tanmai, it's great to have you on the show.
Hey, Swapnil, hey, everybody.
Of course, we will talk about today's topic is more about data complexity. But before that, just quickly remind our viewers what is Hasura all about.
Hey, folks. So, Hasura is a platform to help folks build data access layers with GraphQL. So think of it as the layer between your data systems and your services, or between your data systems and your applications. You typically need something that sits there. You build it by hand, you use a bunch of tools. Hasura kind of sits at that layer, gives you a GraphQL API, and helps multiple people who are involved in this dance of data access work together easily.
Let's talk about data complexity. Do you see that things are getting easier for organizations? I mean, there's a data sprawl, there's data explosion, so I don't think things are getting easier, but or things are getting more complicated. And if they are getting complicated, beyond just dealing with the tech challenges that comes with complexity, what are some of the other issues that organizations are facing because of this complexity?
Yeah, no, that's a very good question. So, like you rightly said, data is kind of sprawling, data is everywhere, new data is getting created, and we're figuring out more and more use cases for what to do with that data, right? And as there is kind of, there are a few driving things that are causing people to require data access to be more real time, to be more integrated, and to come from multiple places, right? So what you're having is you want to build applications that are integrated experiences. So when you're building an application, for the same application, you want to bring data from place one, some data from place two, some data from place three. With starting to build AI applications need access to data from multiple places at the same time to be useful, right? And not everybody has their data all in one place, right? There's lots of kind of needs underneath the surface that are kind of driving that need for de-siloing and simplifying data access. The challenge in dealing with this complexity is that it's partly a technical problem and partly a people problem, right? So at a technical level, being able to unify data from multiple places and make access possible is a hard problem, right? And we're not just talking about analytical access here, where maybe you make everything, you put everything into a data warehouse or something, or you have a data lake. But it's not kind of that situation, but it's a situation where you also need transactional access. You need low latency, high concurrency access to build other services, other applications that need to interact with this data. And so there's a technical challenge on how should we solve this problem of providing access to these multiple data systems in a low latency, high concurrency way, right? And that's kind of the technical part of this problem. The people part of this problem is that anything that we put in this layer from a technology point of view is essentially a two-sided kind of marketplace problem, right? So you have many different producers of data who are trying to provide their data to multiple people. And then you have people who want to consume this data, who want to consume from multiple places, right? So it's like an internal marketplace or platform that you need to set up inside the organization. And if you're not approaching it from kind of a platform strategy point of view of setting this layer up, there's going to be lots of challenges that come up, right? You can imagine that there's kind of people who want to be in a marketplace, but imagine that there is no marketplace, right? Imagine that there's no platform, and the kind of challenges that that results in. I can go into more detail, but that's kind of a big source of where that people complexity comes from, which is a lack of a platform strategy in thinking about this problem.
Of course, there are ways organizations continue to deal with this complexity, this problem. Some of those measures for sure. But what are the things that work for them? How they successfully manage to deal with these data complexities?
When you start to think about it as a platform approach, and you start to think about it as, okay, first you acknowledge this complexity, right? And you're like, this complexity is real. This complexity is holding us back. And so we now need to kind of have a strategic intervention here. And we really need to think about simplifying this today, tomorrow, for the years to come. Um, and so when you start to think of it from that point of view, there's like three pillars of the strategy, or not three pillars, but three phases of this kind of platform that you want to set up, right? Um, Whatever you do to solve for this complexity, what you want to do is you make sure that you set up self-serve, you set up a self-serve platform, right? And the self-service of this platform is on three components. The first part of it is that you should help data owners connect data into the platform. So you imagine that you have a platform. The first part of this is that you want to help people who own data, who own services, data services, connect into the platform as easily as possible. The more easy you can make it for producers to connect data into this platform, the easier it is, right? Because you're not adding burden to them. They can continue doing their own work. From a CI/CD point of view, from a performance point of view, from a security point of view, they can easily kind of connect their data into the platform. The second pillar is that you want to have an API experience that is phenomenal for your consumers, right? So you want consumers to be able to get an API to fetch data from multiple places, to get an amazing API experience, documentation, discovery, their portal, right? All of that kind of internal tooling and internal platform to help your developers from different teams access this data, right? So that's kind of part two. You want to make API consumption self-serve. So you want to connect data self-serve. You want to make consume API self-serve. Now, the third part of this, which is critical, is the part that helps close the loop and bring us back to connect, is this idea of, just like a marketplace, you need to analyze what your consumers are doing and set up a communication model between your consumers and your producers so that consumers can talk about what is missing in the data that they want, right? So consumers have an operating model to tell producers that, hey, this data is missing, this field is missing, this data is not good enough. I know that this data exists in the org somewhere, but it's not available on the platform, right? So when you kind of think about it as connect data, consume APIs, discover demand, right? You want to discover that demand more, you want to analyze that demand, and then you want to kind of use that to connect more data or improve the data that is connected. So you're kind of creating this platform approach to solve this problem in a way that is incremental and that is compounding in its effect, right? Because now you can start small. You can start small with a little bit of data, some APIs, some people getting productive, and then based on their demands, add more data into the platform, make more people productive, and so on and so forth. Kind of just like any marketplace, right?
Can we also talk about the data delivery network version 3 announcement and give us an overview of DDN? And then with version 3, what new features and functionalities will be available to users?
We have we built Hasura version 1, Hasura version 2, and now we built Hasura version 3, which is the next generation open source GraphQL engine. And using Hasura version 3, we've built out our infrastructure and platform product that kind of solves a lot of these challenges that we were talking about, which is called the Data Delivery Network, Hasura DDN. Very similar to the name. If the name reminds you of CDN, that's not a coincidence. That's kind of what we were hoping for. Now, CDN was an infrastructure layer that when you kind of think about a CDN, you thought of it as, I have a website, I have some static assets, and I'm going to put a CDN in front of it. Is the first thing that I do. And instantly, I'm going to make it production ready and available to anybody who wants my static content, right? And that's kind of how you thought about a CDN. What we want to do is we want to bring that same experience to real-time dynamic data. So what we want to say is, hey, you've got a database, you've got some data sources inside the organization. The first thing that you should do is connect that into our platform called the DDN, the Data Delivery Network, and we are going to make that available in a production-ready way to any API consumer who wants access to that data, right? Um, and and in two sides of that problem. The first is that connect data experience. What we want to make sure is that it's extremely easy to connect whatever you have into the platform in a self-service way. And there, our key innovations have been on two counts. The first is Hasura used to, for V1 and V2, we used to introspect your databases, your data sources. We used to understand what's inside the database. And we used to bring that up into the API layer by understanding what is inside your database. So let's say you had a users table inside your database, or you had a stored procedure inside your database. What we would do is we would introspect that and then make an API out of it, allow you to customize the API, but we would bring an API out of it available to people, and that would simplify things. What we've done with V3 and the key part of DDN is that we have done that with code as well. So you can introspect code. So if you have Java Spring Boot, TypeScript, whatever you have code, we can look at that code and then bring that into the API as well. So that way you can connect data, connect code, and into the DDN, which is going to provide an API, an amazing API to the API consumers. And that's kind of been a big part of what one key innovation in DDN to make it easy for people to connect data into the platform.
Anything else in terms of this V3, or that's?
I would say that the most relevant, especially for developers, and this has been a core amount of engineering work. The API layer that DDN provides is extremely high performance, low latency. It's planet scale. It's deployed to 100 regions, 100 AZs all over the planet. And one of the things that we put in a lot of effort into was to arrive at a pricing model that feels great to developers. And we've been able to provide an offering to developers where they can create an API, what we call a super graph, on top of their data, on top of their code, run it at any scale whatsoever for free. So that means if you have 1 request per second, 10 requests per second, 1 million requests per second for your API, if you're a developer and you're building this out for hobby project, local development, whatever it is, you can actually run your super graph entirely for free on the DDN. And this was a tremendous amount of engineering effort on our side to make this possible, to decouple actual API usage from the pricing of this API platform. And I think that's something that's going to resonate with our developers a lot. It's going to make a lot of things possible. Again, very similar to a CDN, where somebody like Cloudflare came in and completely changed the game for me as a developer. I could just take my website and connect it into Cloudflare entirely for free. It was mind-blowing as a developer. We want to bring that same experience to developers on the data side.
You mentioned Supergraph. Can you just go a bit deeper into Supergraph, what they are and how organizations are using it? Of course, you mentioned briefly about that, but let's go a bit deeper into that.
Yeah, so we were kind of talking about data complexity, the data platform, right? People need to connect data, consume data, discover kind of demand on how that marketplace is evolving. On the consume side, when you want to consume these APIs and you want to consume data from multiple places, one of the reasons why that there's so much complexity in data access is that you have too many places to go to fetch a particular piece of data. And this is kind of called the N+1 problem, right? So for example, let's say you're building a Gen AI application, right? And if you're building this AI application, you want to build a internal customer intelligence service or application, right? And so you want this Gen AI application that you have to work on your data and to be able to answer questions like, tell me, for my enterprise customers in the US, in the first 30 days of their onboarding, what are the top billing issues that they're facing, right? This is a great question, great use case for Gen AI, right? Because when you look at the number of support tickets that you have on file, analyzing which ones are related to billing issues, what the top kind of billing issues are, you can get a superhuman AI to summarize this for you and actually give you insight that you can look at and get a quick pulse of and get a quick sense of. This task is impossible otherwise, right? You have to literally go through every single ticket, kind of find out what the billing issues are. So let's examine trying to build this AI application and get data access to make this possible, right? You need to first fetch all of the issues that have keyword billing in them, which maybe you could to from a vector search, put it in a vector database, do a vector search, get a sense of what your billing issues are. Now you need to start find out of these billing issues, which tickets came from enterprise customers in the US. Now, this information might be in a transactional database somewhere where, your enterprise customers get logged in, they create an identity, they create an account. That is the information that you want that you might have to fetch from there. And then you have onboarding date, which might be in your CRM because that's the day that their onboarding started, right? This data is now in three places. So I need to do a vector search, but I need to filter it by data in database one. And then I need to filter that by data, which is in SaaS service two, right? This is an API integration task that is very, very complicated, right? This API integration task for somebody to build is not going to be easy, right? So this means that your amazing Gen AI application idea that's going to make everybody productive in your organization is not going to fly. Nobody's going to be able to build this amazing AI app because they can't get access to this data. You can build a toy app, but if you want to roll it out in production, you're not going to be able to actually get access to this data and build something, right? So the idea is to provide a GraphQL API to make this data, to join data from multiple places, to filter across data from multiple places, and to make that API available, right? And as we kind of think about building a GraphQL API that is federating access to multiple domains, that is bringing data together from multiple domains, one of those reference architectures that is starting to um, um, become more popularly used is called the supergraph, right? And so you can check it out at supergraph.io. It's just open reference architecture for how to think about a supergraph platform, how to think about the reference architecture, how to think about CI, CD, how to think about what the technical stack components are. That can help you provide this experience of a GraphQL API that provides access to multiple domains. So that's kind of where that motivation of a supergraph comes in.
One more thing I want to talk about is that we talk about all these technology solutions are there, but what is the role of culture? How organizations can kind of build? I mean, because the fact is, we live in a data-centric world. Beyond data, everything is useless. We build applications to either collect or deliver value through that. So talk a bit about in this data-driven world, what kind of culture organizations should embrace so they can, get more value out of the solutions technologies that you work on, the solution technology that Hasura is providing users with?
That's a great question. I think like as organizations are kind of thinking about the next 10 years, it's a pretty big cultural shift that I think everybody has to embrace. So if you look back at the last 10 years or so, you'd say it's kind of been that era of figuring out cloud, microservices, Kubernetes, service mesh, right? You're kind of transforming your organization, your culture to say, let's ship faster, let's get microservices going, stuff like that, right? So you've kind of had that's kind of been the shift there, right? Now looking forward to the next 10 years, especially in the current economic climate, this culture of there's two kind of things that are emerging that are really important, right? The first part of it is data, which is that data is everywhere. We must make our data available. We must secure our data. We must govern it well. We must become data first, not just internal from a business intelligence point of view, but even in shipping value to our consumers. We need to start kind of using our data much more and thinking about it, right? The second kind of lens also is a lens of productivity, where you're saying, in the current economic climate, you're thinking about your developers and you're saying, how do I make sure that all of my engineers, all of my developers are being as productive as possible? That my team of 60 is able to do everything that we need to do as a business over the next few years, as opposed to hiring more people and saying I need to hire and have a team of 100 people to do this, right? And so when these kinds of like pressures of saying that, hey, let's become more data first, let's become more data driven, that's a bit of a change. And you also at the same time need to make your developers more productive. And these kind of needs start to collide. I think in those kinds of contexts, everything that we talked about from a data platform, from a supergraph point of view, kind of become a very top of mind as a way to solve this problem, right? Like you have a lot of complexity, complexity kills productivity, right? So you need to have a strategic platform to solve that complexity problem so that people become more productive, right? And that is critical. If things are too complicated, people can't be productive. That's a fact. Everybody um, has felt the pain of doing that. And so I think it's that's kind of one lens to it. The second lens, of course, is um, the more you make your data available and the more people can demand data and the more people can deliver data and make it self-serve, and you create that culture of a marketplace of data, a marketplace of APIs that is self-service. Things have good contracts, have API contracts, but data can change and data can flow freely through the organization. The entire org is going to move much, much faster, which over the next 10 years, if you want to survive in the AI enabled landscape, you're going to really have to put your data to work and move much, much faster than the competition. Otherwise, it's going to be a tough road ahead.
Tanmay, thank you so much for taking time out today and, of course, talk about this complexity and how you folks are trying to help organizations deal with this complexity. Thanks for the great insight. And as usual, I would love to chat with you again soon. Thank you.
Thanks, everyone. Thanks, Ahmed.